Welcome to the world of organic chemistry. Today we are going to discuss about three classes of organic compounds which are useful in our day-to-day life as well as in industry. So to begin with, let us move to Unit 11, alcohols, phenols and ethers. To begin with, let us study about the definitions of alcohols, phenols and ethers. Alcohols are hydroxy derivatives of aliphatic hydrocarbons. When one or more hydrogen atoms from an aliphatic hydrocarbon is substituted by OH group, that is hydroxyl group, we will get the class of compounds known as alcohols, generally represented as ROH. So from the alkane RH, one of the hydrogen is substituted by OH group, hydroxyl group, we get the class of compounds known as alcohols, ROH. Like that, phenols, they are also known as carbolic acid. They are hydroxy derivatives of aromatic hydrocarbons in which the hydrogen atom is substituted by a hydroxyl group and the hydrogen atom is directly attached to the benzene ring. Example, from benzene, one of the hydrogen is substituted by OH, then you will be getting C6H5OH and that is a typical phenol or simple phenol. Ethers are another class of compounds. Actually, ethers, in the case of ethers, from an from an aliphatic hydrocarbon, the hydrogen atom is substituted by alkoxy group or aryl oxy group. So, substitution of hydrogen atom of a hydrocarbon by an alkoxy group, that is OR, methoxy, ethoxy, like that. As well as by an aryl oxy group, OAR, gives a class of compounds known as ethers. And they are generally represented as ROR. R and R dash or R and R can be same. Both R can be same or different. Now, let us study the classification of alcohols, phenols. Generally, alcohols and phenols, they are classified into aliphatic alcohols as well as aromatic alcohols. So, what are aliphatic alcohols? Aliphatic alcohols are those in which the hydroxyl group is attached to an aliphatic carbon chain. For example, methanol, ethanol, propanol or vinyl alcohol, the OH group or the hydroxyl group is attached to an aliphatic chain. Whereas, in the case of aromatic alcohols, the hydroxyl group is attached to the side chain of the aromatic hydrocarbon. Example, C6H5CH2OH, it is commonly known as benzyl alcohol or also it is known as phenyl methanol. IUPAC naming is phenyl methanol. The OH group is attached to the side chain of the aromatic hydrocarbon. Now, third classification is based on the number of OH groups or hydroxyl groups present in the alcohol molecule. Alcohols and phenols, they are classified into monohydric, dihydric and polyhydric alcohols depending upon the number of OH groups present in the molecule. Example of monohydric alcohols, ethyl alcohol, methyl alcohol, there is only one OH group present in the molecule. Whereas in the case of dihydric alcohol, there will be two OH groups. Simple example is ethylene glycol, CH2OH, CH2OH. If there are more than two OH groups present in the molecule, we will name it as polyhydric alcohol. Commonly used example is glycerol, that is CH2OH, CHOH and CH2OH. Just like that, in the case of phenols also, there are monohydric phenols There is orthocresol, metacresol and paracresol. So many compounds are there present with one OH group. Similarly, arososinol contains two OH groups and hydroxyquinol contains three OH groups. So these are all examples for monohydrate, dihydrate as well as polyhydrate phenols. Now let us study the fourth classification of alcohols. Based on hybridization of carbon to which the OH group is attached, alcohols, they are classified into alcohols containing sp3 hybridized carbon bonded to the OH group. In that, the first class of alcohols that you have to study is primary, secondary and the tertiary alcohols. Now you can study these examples. In the case of propan-1-nol, you can see OH group is attached to only one alkyl group. Whereas in the case of propan-2-ol, OH group is attached to the carbon which is linked to two alkyl groups. In this case, OH group is attached to the carbon which is linked to three alkyl groups. Therefore, propan-1-ol is considered as a primary alcohol. In this case, since there are two alkyl carbon atoms or two carbon atoms, it is bonded to the carbon carrying the OH group. It is classified under secondary. Propan-2-ol is a secondary alcohol. OH group is linked to the carbon which is carrying three alkyl groups. Therefore, 2-methyl propan-2-ol is a tertiary alcohol. In all these cases, you can see OH group is attached to sp3 hybridized carbon atom. This carbon atom is sp3 hybridized. All these carbon atoms are sp3 hybridized. So that is the first class of compounds. Then second class of alcohols is allylic alcohol. In this, the OH group is attached or the hydroxyl group is attached to sp3 hybridized carbon atom next to a carbon-carbon double bond. Now you can see this example, CH2 double bond CH, CH2 OH. Simplest allyl alcohol. This is known as allyl alcohol. OH group is attached to sp3 hybridized carbon atom. This carbon atom is sp3 hybridized carbon atom next to a carbon-carbon double bond. Or propene 2 and 1-nol, that is the IUPAC naming for allyl alcohol. Just like that, another example for allyl alcohol. There, the OH group is attached to the sp3 hybridized carbon atom. OH group is attached to sp3 hybridized carbon atom. Now here you can see that OH is attached to a secondary carbon atom. Therefore, allyl alcohols can also be primary, secondary or tertiary. In this case, OH group is attached to a primary carbon atom. Coming to the third class of alcohols, benzylic alcohols. In this, the hydroxyl group is attached to sp3 hybridized carbon atom next to an aromatic ring. So OH group is bonded to sp3 hybridized carbon atom which is bonded directly to an aromatic ring. Such compounds, such alcohols, they come under benzylic alcohol. Simplest benzylic alcohol, that is benzyl alcohol, C6H5CH2OH. OH is attached to sp3 hybridized carbon atom. Similarly, 1-phenyl ethanol, that is also another example for benzylic alcohol. Second major classification of alcohols, that is alcohols containing sp2 hybridized carbon bonded to the OH group. Their OH group is directly attached to the carbon which is sp2 hybridized. Simple example, that is a bonded, that is OH group is or hydroxyl group is bonded to a carbon-carbon double bond. OH group is having bonding with sp2 hybridized carbon atom which is involved in carbon-carbon double bond. Simplest example is vinyl alcohol. Another example is phenol. In phenol also OH group is attached to sp2 hybridized carbon atom. Now this carbon atom is sp2 hybridized, and that is bonded to a carbon-carbon double bond. Okay, so these are the examples, typical examples for alcohols containing sp2 hybridized carbon-oxygen bond. Now let us study the classification of ethers. Ethers are generally represented as R, O, R dash, where R and R dash are same or different alkyl groups or aryl groups. So they are mainly classified as first class of compounds is simple ethers or symmetrical ethers. In the case of simple ethers or symmetrical ethers, on either side of the oxygen atom there will be identical alkyl groups. Simple example is CH3O, CH3, that is known as dimethyl ether. Common naming is dimethyl ether. Then in the case of C6H5O, C6H5, there also identical groups are present on either side of the oxygen atom. So that is also another example for simple ether. The second class of ether, that is known as mixed ether or unsymmetrical ethers. In the case of unsymmetrical ether, on either side of the oxygen atom there will be different alkyl groups. Typical example is ethyl, methyl ether. Then another example is methyl phenyl ether. So there are two classes of ethers, symmetrical as well as unsymmetrical ethers. In the case of naming of alcohols, there are two systems followed. One is common naming system and the other one is IUPAC naming system. In the common naming system, alcohols, they are named as alkyl alcohols. For example, CH3OH, they are that is represented as methyl alcohol. Whereas in the IUPAC naming system, commonly we call it as alkanols. Compounds are named as alkanols. Methanol, CH3OH, that is named as methanol since it contains only one carbon atom. Like that, if OH is attached to the long chain, we will name it as N-propyl alcohol since it contains 3 carbon atoms. In the IUPAC naming, propan 1-ol. OH is linked to the secondary carbon, CH3, CH, OH, CH3. Isopropyl alcohol, propan 2-ol. Similarly, CH3, CHOH, CH2, CH3, and that is known as secondary butyl alcohol. OH is attached to the secondary carbon of this long chain. Secondary butyl alcohol, that is known as butan 2-ol. Isobutyl alcohol, their OH is attached to a primary carbon atom that is linked to the chain, that is CH3 twice CH, and therefore the name is isobutyl alcohol or 2-methyl propan 1-ol. Tertiary butyl alcohol, that is a tertiary alcohol, 2-methyl propan 2-ol. So you have to be familiar with the examples that are present in the concerned topic. There are tables associated with the names of compounds, alcohols, phenols, and more examples are also given. So you should be familiar with the more examples that are present in the concerned chapter. Now let us study the naming of ethers. As I have told you earlier, ethers have the general representation RO, R dash, where R dash and R can be either same or different. Now the common way of naming ethers, in the common naming system, it is named as dimethyl ether. Since there are 2 methyl groups, we call it as dimethyl ether. Always the ending word will be the ether. In the name, the ether will be used as the ending word. In the IUPAC naming system, it is named as alkoxy alkanes. Ethers are usually named as alkoxy alkane. Now one of the group is taken as OCH3 group is taken as methoxy. So the name will be methoxy methane. Now if it is an unsymmetrical ether, where there are two different alkyl groups, we have to arrange it in alphabetical order and the ending word should be either. Methyl group is there, phenyl group is there. So the naming will be methyl phenyl ether. In the IUPAC naming system, which group should be chosen as the alkoxy group? That is always taken as the smaller group. So the smaller group moves along with the oxygen. So here the naming will be methoxybenzene. So IUPAC naming will be methoxybenzene. Similarly, in the case of CH3O, CH2, CH2, CH3, the common naming will be methyl N-propyl ether. And the IUPAC, in the IUPAC naming system, it will be 1-methoxy because this carbon is taken as the first carbon atom, Locke number. So it will be 1-methoxy propane. So IUPAC naming can be written as 1-methoxy because we have to specify the Locke number to which the alkoxy group is attached. So 1-methoxy propane. So that is the IUPAC naming. Now second one represents the common naming of the ether. Now let us study the structures of functional groups of alcohols, phenol and ethers. Now I have taken the example of methanol. Consider the structure of methanol. In this structure, the carbon atom as well as the oxygen atom is sp3 hybridized. So consider the case of this oxygen atom. Out of the 4 hybrid orbitals, 2 of the hybrid orbitals are used for making sigma bonds between carbon atom and hydrogen atom. The remaining 2 hybridized orbitals contains the lone pair of electrons. And due to the presence of this lone pair of electrons, there is lone pair repulsion. As a result, the bond angle is reduced to 108.9 degree compared to the tetrahedral bond angle, that is 109.5 degree. So the reduction in bond angle is due to the repulsion of the lone pair electrons. Now coming to phenol. Here also oxygen is sp3 hybridized, but the carbon is sp2 hybridized. As a result of that, the bond angle, the bond length is decreased, but the bond angle is somewhat very close to tetrahedral bond angle, 109 degree. But why this bond length decreases compared to this CO bond? This CO bond is less, 136 picometer only. Now there are 2 reasons for that. The first reason is due to the double bond character acquired by their conjugation, that is due to resonance. Pair of electrons will be moving into the benzene ring. As a result, the single bond acquires a partial double bond character and hence the bond length decreases. Second reason is that oxygen atom is attached to, or OH group is attached to sp2 hybridized carbon atom. This sp2 hybridized carbon atom is more electronegative compared to that of sp3 hybridized carbon atom in methanol. Therefore, the electron cloud will be attracted more closer and hence the bond length decreases to 136 picometers. Coming to ethers, methoxymethane, the bond angle is increased to 111 or 111.7 degree. What is the reason for that? There are also lone pair of electrons, lone pair repulsion is there. But apart from that, due to the repulsion of these bulky alkyl groups present on either side of the oxygen atom, the bond angle is little bit increased to 111.7. Even though there is lone pair repulsion, the electron cloud repulsion is more, predominantly more, and hence it is increased to, bond angle is increased to 111.7 compared to that of tetrahedral bond angle 109.5 degree. So dear students, for today's session, this much topic is enough. We will meet in the next class with further topics. Thank you.